In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star.
The moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020's CD3, are rare. They need to have specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. A transient lunar phenomenon is one of the most enigmatic things happening on the moon. It's a short-lived light, color, or some other change on the satellite's surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes. But there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the moon. One of the mission participants noticed that one part of the natural satellite was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. There might be more metals, for example titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would be easier to walk on the moon's surface, but it would be more dangerous too. Your feet inside a heavy spacesuit would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden under the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared in the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. There's no air on Earth's natural satellite, but then how can it be rusting? scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. But even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. The Earth and the moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The moon creates tides in the Earth's oceans. They pull back at the moon and make it speed up. This, in turn, moves the satellite to a higher orbit. In prehistoric times, the moon was way closer to our planet than it is now. Luckily, we aren't going to lose the moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the moon away with such a force. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several hundred millions of years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface, about 30 miles long and 60 miles wide. The cave's likely to be the result of 3 billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface, discovered by NASA, might be the openings to lava tubes. The moon's orbit around the Earth isn't a circle, it's an oval. That's why the distance between our planet and the satellite varies from over 225,000 miles to more than 250,000 miles. There's very little seismic activity going on inside the moon. Yet, many moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fractures appear in the satellite's surface, and gases escape through them.
The very first known interstellar object, or ISO, to pay a visit to our solar system was a rocky, elongated interloper with a slightly reddish hue. It was spotted in 2017 and was dubbed with the Hawaiian name Oumuamua. It was almost 10 times as long as it was wide, and it was extremely unusual. Objects in our solar system are rarely shaped this way, so astronomers hoped it could provide some clues into how other star systems form and function. For hundreds of millions of years, longer than I've been around, this bizarre guest has been wandering through our home Milky Way galaxy, not bothering to settle down in some star system. And then, it came across the solar system. After the space traveler was discovered, hundreds and probably even thousands of telescopes all over the world, including ESO's Very Large Telescope in Chile, sprang into action. They started measuring the object's orbit, its color, and brightness. That's when it became apparent that the space rock had an unusual orbit. Some astronomers suggested that Oumuamua was emitting hydrogen it had picked up during its journey between stars. This was a simple explanation for the mystery that had evoked lots of outlandish theories. When this bizarre guest was first spotted upon entering the solar system, scientists were not sure what its nature was. Some claimed it was a comet. Others disagreed, saying it didn't have the features typical for comets: a visible long tail and a coma, which is a cloud of gases surrounding the nucleus of a comet. Plus, its shape was different from that of other comets. The only thing that made Oumuamua more comet-like was the way it accelerated as it went away from the sun. The unusual object started to slow down on its way out, but in a strange way, as if not only gravity was in play there. It seemed like something was creating a force to counter this gravity. But unfortunately, this theory didn't quite fit either. The problem is that comets usually have large quantities of water ice on their surface, and as the sun heats this ice, it gets ejected as jets of gas. Those jets act as mini rocket boosters. But Oumuamua not only had no tail whatsoever, but it was also too small to capture enough solar energy to support this kind of activity. Of course, this mysterious space visitor caused some more outlandish theories. For example, some people started to claim that Oumuamua could be a spacecraft sent by a civilization living in another star system. However, scientists found a better explanation. A comet that is traveling between stars gets cooked by cosmic radiation. These rays penetrate thick layers of ice, converting up to 25% of water molecules into molecules of hydrogen. And then, this trapped hydrogen gets released when some star warms the comet. The effects of this process are almost invisible. This might be the reason why we didn't see a spectacular tail accompanying Oumuamua. At the same time, the potential comet was so small that this could produce enough force to power its acceleration. As for the amount of ice released as Oumuamua was coming closer to the sun, it was likely too small for astronomers to spot it. Now, even though Oumuamua was the first known interstellar object to enter our solar system, it wasn't the last. In August 2019, comet 2I Borisov visited us, becoming the second ISO astronomers managed to spot. Now, no one can argue that there simply must be more visitors from faraway star systems than those two. ISOs are rare, but our solar system is pretty old. It must have been capturing some interstellar travelers over the millions and millions of years of its existence, even though they never stayed for very long. One study has taken a closer look at interstellar objects, and they concluded that these space travelers might be caught not in solar orbits, but in near-Earth orbits. The astronomers working on this project even go as far as to claim that there might be a lot of ISOs in orbit around Earth. Now, finding tiny objects in the vastness of the cosmos is extremely tricky. Think about it. What images of distant areas of space do we usually get? Mostly stars. Sometimes unclear pictures of exoplanets. Even more rarely, it can be disks of debris. But fine detail in small space objects? Almost never. So it's actually lucky for us that other solar systems send their inhabitants to visit us. Because by studying ISOs, we gain insight into the formation, evolution, and functioning of other star systems. Have you ever heard of the Oort cloud? It's the most distant region of our solar system, and it's quite unusual. You see, the orbits of the planets lie mostly in the same flat disk surrounding the Sun. But the Oort cloud is believed to resemble a spherical shell surrounding the entire solar system. It looks like a gigantic, thick-walled bubble made up of chunks of ice and other space debris as large as mountains or even bigger. Astronomers think that the Oort cloud contains billions, if not trillions, of different objects. There might also be a connection between the Oort cloud and ISOs. Because scientists think that interstellar objects might outnumber those from the solar system in this region. Even though no one has ever observed the Oort cloud directly, astronomers are sure it does exist. They made such a conclusion after observing the distribution of comets in our solar system. The Oort cloud could have formed from debris in the early solar system, but some experts argue that the largest part of this unusual shell could be interstellar in origin. If travelers from other star systems are as common as some studies suggest, lots of the bodies on the edges of the solar system are likely to have originated in other systems. Sadly, this theory hasn't been proven yet. Now, since we've been talking about comets, not Cupid or Donder or Blitzen, one of them has recently approached the Sun at breakneck speed. It was 96P Mach-Hulse 1. This comet is around 3.7 miles wide, and astronomers think it might have arrived from outside the solar system. The NASA European Space Agency Solar and Heliospheric Observatory spacecraft has been monitoring the comet. So look at this. That's the comet's tail. It's mostly made up of gas. It's trickling behind frozen chunks of ice that are getting heated by the radiation coming from the sun. In some cases, a comet can have two tails, one made of dust and the other consisting of gas. And each of them can reach hundreds and, in some extreme situations, even millions of miles in length. In 2008, scientists analyzed the material left by 150 comets. They found out that the comet we're talking about was quite low in carbon and didn't contain a large enough amount of some other typical materials. This could only mean one thing: the comet was an interloper coming from another star system. It may have been ejected from its original solar system by the gravity of a large planet. After that, the poor homeless thing probably spent a large amount of time wandering around space, until it came across Jupiter. The gas giant could have bent the comet's trajectory, trapping it in orbit around the Sun. There's one more theory. According to it, the comet formed in a poorly studied region of the solar system, and it has this weird composition due to its repeated journeys around the Sun. Now, scientists are watching the comet with anticipation, like Christmas. Since it's an atypical one, both in its behavior and composition, they don't know what they will see, which makes the whole process even more exciting. Most comets falling toward the Sun are quite small, not more than 32 feet across. That's why they burn up as soon as they come close to our star. But the sheer size of Mach-Hulse 1, which is more than 2/3 the height of Mount Everest, seems to protect the comet from evaporating completely.
Do you know that these days our planet has not one, but several moons? Well, kind of. Astronomers have recently discovered another moon orbiting Earth. But it's not what you might be imagining. It's actually an asteroid trailing along beside our planet in a complex semi-orbit. The asteroid was named 2023 FW13, and instead of simply orbiting our planet like the Moon does, it orbits the Sun. But its orbit is so unusual that it causes the asteroid to circle Earth too, keeping it in roughly the same area as our planet, even though it doesn't orbit it directly. You've probably already realized that 2023 FW13 isn't the kind of moon where we could send a mission. It's way smaller and farther away than our natural satellite. The newly found space object is a mere 50 feet across and is floating 9 million miles away, and that's when it's the closest to Earth. This distance is around 35 times as great as that between our planet and the Moon. On the other hand, cosmically speaking, it's just next door. For the first time, the quasi-moon was spotted by astronomers at the Pan-STARRS Observatory on Haleakala in Hawaii in March 2023. Now, a quasi-moon is a space object which shares a similar orbital path with a planet, even though it doesn't orbit this planet directly. Plus, it has a steady relative position to this planet. True moons always keep a relatively consistent distance from their parent planet, but quasi-moons have more complex paths. That's because of the combined gravitational influences of the Sun and the planet itself. Quasi-moons usually have horseshoe or tadpole-like orbits. To put it simply, you can see them travel ahead or behind a planet when it orbits the Sun. Such an orbit is truly unusual, and it occurs because the gravitational pull between the Sun, the planet, and the quasi-moon results in a complex dynamic, leading to a delicate balance in the trajectory of the quasi-moon. When a quasi-moon moves ahead of a planet, it tends to slow down with time, and in the end it falls behind because of the gravitational influence of the planet. Similarly, when a quasi-moon falls behind at first, it later starts speeding up and begins to move ahead of the planet. This is what creates that horseshoe shape if you look at this dance from a fixed point in space. At the same time, the orbit will look like a tadpole from the perspective of the planet. Scientists love quasi-moons because they present great research possibilities. Their interesting orbits make them perfect for studying gravitational influences and the intricacies of space mechanics. Plus, they're usually close to their parent planets, which can also offer insights into the formation and evolution of planetary systems. And who knows, maybe at one point in the future, they'll help us with space exploration. Missions to such quasi-moons could give us important information about different celestial bodies and help with the exploration of the solar system. But let's get back to our tiny moon. While it's still being studied, current data suggests that 2023 FW13 entered its current orbit at least 2,100 years ago. And according to simulations based on preliminary orbital calculations, the quasi-moon will accompany Earth for another 1,700 years or so. The good news is that the asteroid won't end up on a collision course with Earth, despite traveling relatively close to our planet. A few years ago, another asteroid was pulled into Earth's orbit and started to travel along with our planet. No larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet. Called 2020 CD3, it became our temporary mini-moon. It wasn't going to stay with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. 2020 CD3 will make another close pass to Earth in March 2044, though it will most likely not be caught by Earth again because of the greater approach distance. Temporarily captured objects, such as this one, are rare. They need to have a specific direction and speed to be captured by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. And in 2016, astronomers discovered another space rock and called it Oumuamua. There was one absolutely amazing thing about this space traveler. Astronomers suspect that this celestial body could have formed after splitting off the moon during an ancient collision with an asteroid. Yes, it means it might be a piece of our moon. When specialists examined the space body and analyzed its composition, the results didn't match any of the more than 2,000 near-Earth asteroids studied before. Oumuamua was too tiny and too far away for regular telescopes to study it. That's why the researchers had to find a more powerful telescope to learn more about this unusual find. After using the Large Binocular Telescope, one of the largest optical telescopes in America, and the Infrared Lowell Discovery Telescope, the scientists finally figured out what the asteroid was made of, and what they had discovered surprised them. The asteroid had light spectra similar to those of the samples of lunar material delivered to Earth by the 1960s and 1970s Apollo missions. Astronomers admit that there might be other asteroids with the same spectra, but so far they haven't found anything like that. Oumuamua is another quasi-satellite of our planet. Its orbit is a bit tilted and slightly elongated, so the rock keeps leaping ahead and then falling behind Earth. In other words, it performs constant loops around us. At its closest, the 130-foot-wide asteroid gets to the distance of around 40 times that of the Moon. According to the results of orbital analysis, the rock has been following Earth for at least 100 years. We found more than 480 lunar meteorites on our planet. It may mean that pieces of our natural satellite travel through space pretty regularly. And Oumuamua might as well just be the first discovered large rock split off the moon as a result of an ancient collision. Now we've already talked about quasi-moons. Let's find out more about asteroids. These space bodies are often called minor planets or planetoids. They're usually rocky leftovers from the early formation of our solar system that occurred around 4.6 billion years ago. They are mainly found in the asteroid belt between the orbits of Mars and Jupiter. Asteroids can be very different in size, from tiny dust particles and modestly sized boulders to huge bodies reaching 600 miles across. Asteroids often have irregular shapes, especially smaller ones. At the same time, large space bodies can have more of a spherical shape. Unlike planets, asteroids don't consist of layers. They're made of different kinds of metals and rocks and have no atmosphere. Funnily enough, some asteroids have moons of their own, and there are even asteroid binaries where two asteroids of similar size orbit each other. The asteroid belt located between the orbits of Mars and Jupiter has the largest number of asteroids in our solar system. There are millions of space rocks there of various shapes and sizes. But despite such a huge number of asteroids, they're widespread across the vastness of the cosmos. And if you accidentally wandered into that region, the chances of your spacecraft colliding with an asteroid would be quite low. But even though most asteroids prefer to stay in the asteroid belt, some of them make their way closer to Earth. Those are called near-Earth asteroids. Experts monitor such asteroids because of the potential risk they pose. In the past, they did affect our planet. Think of that large one that most likely wiped dinosaurs off the face of the Earth. NASA and other international space agencies have sent a few missions to research asteroids. Some of them aim to retrieve samples from asteroids and return them to Earth for study.
You know, many different things have nothing in common at first glance. The appearance of mysterious clouds over Stonehenge and the migration of wolves in Canada, patterns on the wings of a Caribbean butterfly, and strange footprints on the moon's surface. These are all random facts, but people can see connections in these events. Let's see how it can happen and where it can lead to. Imagine reading some crazy article on one of the unreliable sites, forgetting about it, and then beginning to notice small details in the world that might indicate that the information in this article is true. You realize you've learned something unusual, but for some reason, other people don't see it or don't want to see it. You try to tell them, but no one wants to listen to you. And some people even think you've gone mad. Let's stop for a moment and see what kind of article you've read. So, in 2017, one not-so-truthful site published a story about a ship from another planet called Black Knight that had been spying on people for 12,000 years. But not long ago, agents from a secret organization managed to destroy it. Sounds like absolute nonsense or a plot for a cheap sci-fi movie. Of course, you don't believe it. But a few years later, you find a story about Nikola Tesla. Let's fast forward to 1899. The famous scientist was sitting in his laboratory in Colorado Springs conducting radio experiments. Suddenly, his receiver caught a strange radio signal. Then, after a while, another one. The signals came in with the same time interval, as if someone wanted to send a message. Nikola Tesla realized it could be something from extraterrestrial civilizations that were trying to start a dialogue with people using the most universal language, math. He also reported about this event in a magazine at the beginning of the 20th century and added that he hadn't deciphered the message. Okay, now let's forget about it and see what happened next. In 1927, an engineer from Oslo, who was fond of radio devices, was sending signals into open space. He was surprised when, sometime later, the same signals began to return to his receiver. It was as if the signals bounced off something big and echoed back, or something received these messages and then sent them back to the sender to make an acquaintance. The man quickly reported his discovery to scientific journals, and perhaps someone connected this event with Nikola Tesla's words about strange signals from space. All this were just prerequisites for the Black Knight. But the most exciting events started decades later. In the 60s, Time magazine published an article that said that the U.S. had discovered a satellite orbiting Earth and using unknown technology. A couple of years later, Project Mercury astronaut Gordon Cooper reported that he had seen a strange object during his spaceflight. But the Black Knight became really famous only in the late 90s, when NASA published a series of images of a mysterious object. During the first flight to the ISS, astronauts noted weirdly shaped somethings and took several pictures. Then someone gathered all the facts, collected all the information about the black satellite, and discovered that it had been flying around our planet for more than 10,000 years. How did they figure it out? People managed to calculate the age of those radio signals that Tesla and the engineer had received. If this is true, the Black Knight appeared much earlier than the Sumerians in ancient Egypt. What if this satellite helped build pyramids and majestic temples? What if it had been watching over our development all this time and transmitting this information to another planet? What if mysterious images ancient people drew depicted the satellite? People began to suspect NASA and other space agencies of hiding information about the black object to prevent panic. And now, after having received all the data about the mysterious satellite, you might begin to suspect that the bizarre article may actually be true. This news is so improbable and ridiculous that no one will believe it. If you want to hide something, hide it in plain sight. And so, together with other enthusiasts, you start hunting for any information about the mysterious ship. You create forums, post photos of unknown objects, and become obsessed with this topic. You really believe in the reality of the Black Knight. Moreover, you don't want to question its existence, and people reading your articles do the same. Congratulations! You have become an ideal candidate for creating fake news in the yellow press. Such myths and urban legends seem attractive. The human brain feels pleasure when it finds fake secret information. The feeling of mystery, adrenaline, and shock can cause psychological addiction. That's why the stories about the Black Knight are still alive. Mysterious facts seem logical, and people stop seeing information that refutes their theories. The case of the Black Knight is no exception. The fans of this black object believe that Nikola Tesla received signals from some space civilization. But for some reason, they don't attach importance to scientific articles, which say that such radio signals could be sent by giant space objects like pulsars. A pulsar is a rotating neutron star emitting powerful electromagnetic radiation. Such radiation is often found in space. These radio waves don't imply the presence of a mind and a sender. The cosmos is full of such signals. The technology for detecting such objects were created in the 60s. Or maybe Tesla's device caught a signal coming from our planet. Besides, the scientists didn't say anything about the Black Knight. So why did people connect these two events? That story with the Norwegian engineer is still unexplained. Yes, his signals returned as an echo, but this had nothing to do with the flying object in question either. You might as well say that the satellite somehow influenced the Titanic. There's no logic in such assumptions. Strangely, no one connected the Black Knight with the Yeti or the Kraken. Now, let's return to that Times article about a strange object flying around Earth. It also stated it was a fragment of an American reconnaissance satellite. But fans of myths and legends apparently didn't notice this explanation. As for astronaut Cooper, who is said to spot some object during his mission, he actually saw nothing. He even showed a transcript with no reports about the black satellite. However, some believers in other civilizations keep silent about this fact. So, the main proof of the Black Knight's existence is the photos taken during the first flight to the ISS. The astronauts noticed this strange object and took pictures, but it wasn't a surprise for them because some part of the ship broke away during some work they did outside. It was a piece of thermal coating. The astronauts sent the photo to NASA, and the space agency assigned it a personal number, as it does with all such objects. A few days later, the Black Knight fell out of orbit and burned up in Earth's atmosphere. Almost all this information was recorded in official protocols. One of NASA's engineers, who knew the photographer of the black satellite, explained that those famous photos depicted an ordinary piece of the ship. There was nothing fantastic about it. But the fans of extraterrestrial rockets must have missed all this information. All these myths have long been debunked, and all the false facts have been refuted. But the Black Knight continues to live in many people's minds and on the pages of the yellow press. It has become a link between many reports of strange flying objects. Over the years, hundreds of stories have appeared about secret laboratories with extraterrestrial technologies, about NASA hiding secrets, and about creatures from other planets. And many people connected these myths with the black satellite. It has stopped being a real physical object. Now it's a cultural phenomenon. Remember how the main symbol of extraterrestrial civilizations was a flying saucer? It's not trending anymore. Today, the symbol is a black, weirdly shaped stone. Don't be fooled. Every April, a group of scientists observes the faint glow of asteroids passing by our planet. One year, they realized there was something weird shimmering in their telescopes. The team expected it to be another asteroid, but they ended up very surprised because what they discovered was an unusual space rock that didn't consist of the minerals that usually make up asteroids. It was made of silicate, the material mostly found on the moon. They named it Oumuamua, which is a Hawaiian word that means wobbling celestial object. The rock didn't match any near-Earth asteroids scientists had already been familiar with. Instead, that piece had a pattern of reflected light similar to that of the moon rocks astronauts had brought back from NASA missions. This fragment turned out to be a quasi-satellite, which is a kind of asteroids that orbit both our planet and the Sun. It repeatedly circles Earth and has a quite unusual tilt. That's the reason you can only see it in the night sky once a year. The fragment is pretty shy, too. It never gets closer to our planet than 9 million miles. That's almost 40 times as far away as the Moon. Plus, this space body often hides in the shadows. Scientists have figured out the piece won't stay in this orbit for a long time. It probably arrived at its current position about 500 years ago, and its orbit is likely to change in the next 300 years. This fragment may not be alone out there in space. There are at least 3 more similar near-Earth objects. They may have all come from the same place. Researchers aren't sure yet about the nature of the rock, but they can find out more about this unusual space object if they send a spacecraft to collect samples and bring them to Earth. That's something China's space agency is planning to do later this decade. Now, the Moon appeared in the middle of chaos. There are several theories about how that happened. The first one claims the Moon used to be just a wandering body, similar to an asteroid. It formed somewhere in our solar system. Once, it approached too close to Earth and got captured by our planet's gravity. The second theory says that our planet was spinning so quickly that some material broke off and started circling around it. One of the largest pieces was the Moon. The third theory says that the Moon was formed at a time when our planet was going through its own formation process. But today, the most widely accepted theory goes like this. Once, a long, long time ago, but not in a galaxy far, far away, Earth collided with a Mars-sized planet. The debris and clouds of dust from the collision gathered around our planet and started circling it. Eventually, something that we today know as the Moon formed there. Apollo missions brought more than 1/3 of a ton of soil and rock from the lunar surface. These rocks show that the Moon had mostly the same building materials as our planet. This might mean they have a common history. If the Moon had been formed somewhere else and had been eventually captured by the gravitational force of our planet, it would have a different composition. Also, if it had been created at the same time as our planet or had once broken off, there would be the same minerals on both the Moon and Earth. But the minerals on the Moon contain less water. Plus, our planet's natural satellite is rich in materials that form fast at high temperatures. Now, the Moon isn't the only space body in the solar system with a mysterious past. Hippocamp is Neptune's moon, discovered in 2013. It's the smallest moon of this ice giant, a mere 21 miles across. It's very close to Proteus, the biggest of Neptune's inner moons. And no, Hippocamp is not a place for big African mammals to spend the summer. Scientists think Hippocamp probably formed from debris after Proteus collided with a comet. If Hippocamp had entered Proteus's orbit from some other place in our solar system, the bigger moon would have either swallowed it or booted the tiny moon away. But not even Proteus itself is among the first generation of Neptune's moons. It was formed from the remains of the planet's earliest system of moons. Those first moons were destroyed when Neptune captured Triton, currently the largest of its moons. The main evidence proving the collision was likely to happen is the fact that Triton circles around Neptune backward, unlike other moons orbiting the planet. Neptune captured Triton from the Kuiper Belt. That's an area filled with icy objects and rocky debris stretching beyond Uranus. That means Hippocamp is a third-generation moon, kind of like a second cousin twice removed or something. Now, the Sun also had a turbulent past. Our star appeared about 4.6 billion years ago. It's hard to study its early stages of life since that happened 50 million years before our planet was even formed. But recently, a team of researchers has discovered crystals that are over 4.5 billion years old. Hidden deep within meteorites, they've revealed some things about the past of our Sun. Before the planets were formed, our solar system had consisted of a central star and a massive disk of dust and hot gas spiraling around it. As the dust and gases cooled down, they turned into minerals, including the crystals found in the meteorites that landed on our planet. Those ancient materials were irradiated, unlike some younger substances. Researchers think something might have happened to the Sun after those crystals were formed. Perhaps the activity of our star was less intense then. Or maybe, for some reason, these younger materials couldn't travel to the areas where irradiation was possible. Dwarf planets give us a chance to sneak a peek into the ancient years of the solar system. Around 4 billion years ago, Jupiter's, Saturn's, and Neptune's gravitational forces joined. They sent asteroids and comets hurtling across the solar system, making them collide with different planets. All the dwarf planets from the Kuiper Belt, for example Pluto, Eris, Haumea, Makemake, have their own moons that likely formed after some powerful collisions. Icy debris in orbits similar to Haumea's, for example, can prove the theory of an ancient collision. The debris it created simply didn't have enough energy to float away from the dwarf planet's gravitational pull. Ceres, another dwarf planet, has ammonia-rich clays on its surface. Ammonia isn't stable at the temperatures prevailing on Ceres, but there's plenty of this substance in the outer solar system. It means that Ceres was probably formed in those outer parts and got kicked inward. After all, the gas giants were migrating a lot at those early stages of the solar system. Or the dwarf planet could have formed in an asteroid belt, and ammonia somehow, let's say after a powerful impact, appeared on the dwarf planet. Ceres might help scientists understand icy moons better. The ocean floor on Earth has a high concentration of carbonate minerals, and some parts of Ceres have them too. This means this dwarf planet is like some sort of fossilized ocean world. Many exoplanets, a term used for planets outside the solar system, have also gone through pretty intense collisions in their early stages. This double star system is more than 300 light-years away from us, and its stars are at least 1 billion years old. Even though it's not young, this system still shows some signs of swirling clouds of dusty debris that haven't cooled down yet, which isn't something you'd expect from a star system of this age. This debris is still warm. It means there might have been a strong collision of two planets or some other space bodies of similar size in that region and relatively recently. So hey, everybody just simmer down. Dust particles circle around a young star. They stick together and grow bigger with time. That's how planets form. The leftover dust often settles in some distant cold areas. An example in our solar system is the Kuiper Belt. It's located far away beyond Neptune. As solar systems evolve, those particles keep colliding until they're so small they end up being pulled into nearby stars or kicked out of the system. Uranus spins on its side if you compare it with the rest of the planets in our solar system, and the only way we can explain it is a powerful collision in the past. Something much bigger than a regular comet or some other space body of similar size likely hit Uranus and knocked the planet on the side. It was probably a planet twice the size of Earth. It could be a protoplanet. This is a space body made up mostly of ice and rock that orbits a star and is likely to develop into a planet sometime in the future. Anyway, the fallout from the impact smothered the core of Uranus. It prevented the heat inside the planet from escaping. This might explain why Uranus has extremely cold temperatures on its surface. Man, bring a jacket and a blanket.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, In recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project: figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000, from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. and L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides. So they're intentionally avoiding us because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination.
We fly away from Earth to look at it from a distance. It glows like a holiday tree. Big cities look like yellow spots at night, and during the day, we see strange structures, like a palm tree-shaped island in the UAE, or a dark band that runs all the way through China, the Great Wall. These are traces of human existence. Now let's point our telescope at other planets. Mars? It's just an empty, endless desert. Venus? Only rocks and volcanoes. Even if we look into distant space, all the planets out there are deserted and lifeless. Not a single trace of an extraterrestrial civilization. Many people are convinced that life on Earth isn't unique at all. Here's our galaxy. There are billions of sun-like stars. And here is the entire observable universe with billions of such galaxies. There's an almost infinite number of stars, and near each of them, there may be habitable worlds. But we may not have found life on other planets because it hides from us under the surface. For example, there's Europa, a satellite of Jupiter, slightly smaller than our moon. Its structure resembles a soft-boiled egg. Its surface is a hard crust of ice, but if you take a big enough drill, you can get to the liquid yolk, an ocean of water. Jupiter and its satellites are very far from the sun, so it's quite cold there, about 270 degrees below zero. So liquid water instantly turns to ice. But Jupiter has a strong gravitational force that causes a lot of friction inside Europa, and its core heats up. The heat melts the ice, and we have a watery ocean under the surface. Water is the foundation of all life, so there could be simple bacteria in that ocean. And who knows, maybe there are other life forms out there. For example, weirdly shaped fish. Because of the weak gravity, their bodies are built differently, or something like whales feeding on plankton. In 2009, scientists found a planet that is completely covered by an ocean, GJ 1214. It's about 40 light-years from Earth, and about 75% of its mass is water. Still, the temperatures on this planet are so high that water evaporates and takes the form of superliquid water. There's so much steam that it feels as thick as water itself. No life could exist in such conditions. But scientists have recently found at least 24 planets better than Earth and called them superhabitable. These planets orbit distant stars in their habitable zone. It's the sweet spot at a perfect distance from the star. In our solar system, Venus, Earth, and Mars are in this zone. A superhabitable planet must be 10% larger than Earth and have stronger gravity. That way, it can have a denser atmosphere. A temperature 8 degrees higher than on Earth would make the planet more humid. This would encourage a variety of living organisms there. These planets may be great for life, but it's hard to tell if there is life there already. The main marker that would confirm the existence of an advanced civilization there might be radio waves. Imagine a habitable planet similar to Earth. In the process of evolution, intelligent beings appeared there, like humans. They're much taller because of low gravity, and their eyes are adapted to the light from another star, much brighter than the sun. Sooner or later, this civilization will have to use radio waves to communicate with each other. We can think of these waves as loud sound from speakers. Here's Earth. We're now actively using radio waves, and the noise coming from our planet is pretty serious. If a neighboring planet had radio telescopes, big dishes that catch these waves, they would realize that life is blooming here. There are many radio telescopes on Earth that are pointed into distant space, waiting for a signal from aliens. But we haven't received anything yet. Still, that doesn't mean there isn't a planet somewhere in the universe that emits radio waves. It's all about distance. We're jumping 200 light years to another star. Suppose there's a planet X where life exists. The civilization here is advanced enough to use radio waves, so they release the first wave into space. Our radio telescopes won't be able to pick it up until 200 years later. This also works the other way around. Radio communication on Earth has only existed since 1895. Our radio signal won't reach Planet X until 2095, and only then the aliens will hear our voice. But this radio noise doesn't stay for long. Every year, our technology improves, and our radio noise decreases. We're beginning to use mobile communication, cable TV, and fiber optics. This all reduces the volume of our planet in the radio spectrum, and soon we will simply become invisible to other planets. The same thing is happening on the other side. So, the radio waves coming from civilizations are a brief blip on the cosmic scale, and we can't accept radio silence as proof that extraterrestrial life doesn't exist. A giant telescope, which could take a direct photo of a possibly inhabited planet, would change the situation. We zoom in on the photo, and there it is! We see alien cities with tall buildings and lots of antennas. But now, we can't look that far away. We can take pictures of Mars and its satellites, and even their quality misleads us. For example, Cydonia. It looks just like a human face on Mars. We thought there used to be an ancient civilization there that made some sort of sculpture or memorial. More extravagant theories said it was the remains of a giant human, and there's a whole body of it under the sands of Mars. But in fact, it was just a hill. Strong winds blew out some hollows there, and when there was a shadow in those hollows, we took them for human eyes and a mouth. Or a monolith on Mars's satellite Phobos. We found a smooth rock there that was almost as tall as the pyramid of Cheops. The news has spawned many theories about the civilization that built it, but it turned out to be no more than a rock. The infinite number of stars and worlds around them almost guarantees the existence of other civilizations, so why wouldn't they come to Earth, right? We think that life throughout the universe develops in similar scenarios. The emergence of simple life forms, followed by evolution, and growth of a technologically advanced civilization. But, just like on Earth, cataclysms happen there too, causing mass extinctions. Meteorites, for example. Perhaps there was a civilization out there ready to go into outer space, but a huge meteorite, like the one that wiped the dinosaurs off the Earth's surface, made that civilization disappear, and life on that planet began a new cycle from scratch. In addition, the more advanced the civilization, the greater the risk of its self-destruction. Scientists might conduct experiments in machines like the Large Hadron Collider and accidentally create a black hole there. It would begin to swallow everything around it and grow in size. Soon, all the super-developed cities of this civilization and the entire planet would simply disappear. Another possibility for super-advanced civilizations is to travel through wormholes. Those are tunnels in space-time between universes. Aliens might travel through them and lose interest in going back. But it's also possible that life on Earth is unique. That's because our planet was formed thanks to a number of incredible coincidences. The first is the location of our solar system in the galaxy. In the Milky Way, there are constant fireworks of exploding supernovae. The radiation from these explosions destroys everything around it at great distances. Our solar system is right in the sweet spot of the galactic orbit where we're safe from such explosions. Another factor is the moon. One theory of the formation of the moon says that about 4.5 billion years ago, a meteorite the size of Mars crashed into us. If the impact had been straight, the Earth would have just broken apart. And if that meteorite had only scratched the Earth, the pieces would have just flown away. But the collision occurred precisely so that part of the meteorite remained in Earth's orbit and formed the moon. Then, the moon stabilized the Earth's rotation and heated our core with gravity. Only then, our planet developed a magnetic field, which protects us from the solar wind. Other scientists believe that life outside Earth may be biochemically different. Carbon and water are the basis of our bodies, but carbon could be replaced with silicon or phosphorus, and water could be replaced with ammonia or methane. These atoms could form molecules of different shapes and perhaps assemble into a living organism. Life based on such elements would be unlike anything seen on Earth.